vector of a point starting from the origin. Whenever we read a vector starting from the origin, we always call that vector a position vector. Let's take some examples. Let me mark a point here, B. This point is 3 units on the horizontal axis from the origin. It is 3 units to the right on the horizontal axis and 3 units, upwards on the vertical axis. So this is position vector OB. OB is the position vector of B. I don't need this anymore. Also, let me mark another one here as OC. OC is the position vector of C. I need to put an arrow. So this is 5 units on the horizontal axis. 5 units on the horizontal axis from the origin and 1 unit on the vertical axis. The distance of C is 5 units on the horizontal axis from the origin and 1 unit on the vertical axis. So let me mark a few more. As I mark, you easily see what their dimensions are. Let me mark this OD. OD. Let me mark another one here. OE with an arrow. Let me mark one here too. OF. Let me mark another one here. It's not straight. This is OG. Let's make this OG. Let's put another one here. Just like 2 or 3 on each side of the Cartesian. Let's make this one OH. Let's make this. Put another one here. That's OA. Let me put one here too. OY. Let me put another one here. Let's make it OM. So let's just have these few examples as our position vectors. I can write each of them. For each of them, we can write their dimensions. OA is, let's start from OA. The position vector OA is 3 units from the origin. It is 3 units on the x-axis. Its distance is 3 units on the x-axis, and 5 units on the y-axis. That's vector OA. So vector A is 3i plus 5j. The position vector OA. That means the position vector OA is 3i plus 5j. Let's go to OB. The position vector OB. We are going to read it together. The position vector OB is what? Is from the origin, it is 3 units on the horizontal axis and 3 units on the vertical axis. That's 3i plus 3j. The position vector OB is 3i plus 3j. Let's do OC. Let me read off OC. The position vector OC, what's its distance on the horizontal axis from the origin? Is 5 units here. You can see these broken lines. It is 5 units from the origin on the horizontal axis and 1 unit on the vertical. So that's 5i plus 1j. So position vector OC is 5i plus 1j. For j, I don't need to write the one. We don't write our one in algebra. Let's go to OD. From the origin, D is 3 units on the negative horizontal and what? Minus 2 units negative vertical. So that's minus 3I minus 2j. I hope you are taking note of the way I'm reading there. Coordinates minus 3I minus 2j. Don't forget that I could also write this like this, or write it like this, minus 3 minus 2. So anyone of this is still the same. Well, let's not bother about this for now. Let me write the position vector of OE. OE, how do we write the position vector of OE? OE is 1 unit on the horizontal here to the right, that's plus 1I minus 5j, then minus 5 units on the vertical. So the relative vector or the position vector of E is 1I minus 5j. So E is 1I plus 1I minus 5j. I can also write it as minus 1. I can also write it as plus 1 minus 5. Any of this is okay. Let's write the position vector of OF. Let's write OF now. How do we write OF? OF is okay, F is 1 unit on the negative horizontal and 4 units on the vertical. May not be actually 100% accurate, but you can see it. I'm not using a graph. So that's minus 1I plus 4j. The position vector of F is minus 1I plus 4j. OG, let's write the position vector of G. OG is what? Minus 4I plus 1j. OG is minus, from the origin, minus 4I plus 1j. So let's write that now. Minus 4I plus 1j. I can put the 1 if I like. It's not wrong. It's just not how we write. But okay, OH is, from the origin, OH is minus 3 units on the vertical and what? And what? Plus 5 units. Sorry, minus 3 units on the horizontal and plus 5 units on the vertical. So that's minus 3 plus 5, minus 3I plus 5j. OH is minus 3I plus 5j. OH is minus 3I plus 5j. Let's write OM. OM will be the last one we write. OM is plus 4I minus 5j. OM is plus 4I minus 5j. Let me adjust it a bit to get to minus 5. Plus 4I minus 5j. So 4I minus 5j. So this is how we read the vectors of points on a Cartesian plane relative to the origin, and we call each of these a position vector because they are read from a central point or origin.